So hello friends, in last class we have seen the relation between degree and the radius of the curve. Let us see a small example, right? So given degree, find out radius. So you know degree and you are supposed to find out radius. So let us find out radius by using this. So 1 is equal to 1750 whole divided by r, which implies r is equal to 1750 meters. So similar way, if they give you radius, if they give you radius, then you can also find out degree, right? So now uh, let us see one more concept. Okay, specifications. See, on broad gauge route, the maximum degree that was allowed was 10, and meter gauge route 16 degrees, and narrow gauge route, okay, 40 degree. So he, right. So this was taken from IRPW, okay, Indian Railway Permanent Way Manual and SOD. Okay, right. So if you see this, degree was increasing from broad gauge to narrow gauge, which implies radius is maximum here and radius is minimum here. So here the vehicle can be moved safely at higher speeds compared to narrow gauge routes. Okay, right. Now let us go through this portion versine, right? So now before understanding how to determine versine, let us see why versine is required. See, in field we have larger radius. Okay, in field we have larger radius, so it is very difficult to find them. Okay, so indirectly we'll find out this versine, and based on versine we'll find out radius and then degree, right? So that's why we go for versine, right? Now let us look after the definition of versine. So what is versine? So if you see here, versine is the ordinate distance on curve from midpoint of chord. So what is this? So if you see this here, so let us say this is a circular curve, right? And this is the chord. Okay, so this is the chord, right? This is the chord. Okay, and this is the ordinate. Okay, now from midpoint, so this is the midpoint, from midpoint to, okay, curve, what is the distance that was there, that is called versine. So if you have a ordinate like this, right? So from midpoint, what is the distance, that is called versine. Okay, so it is the ordinate distance on curve, so this is the curve on curve from midpoint of chord. So that distance is called what? Versine of curve, right? So I hope up to here it is clear. Now let us see how to determine this versine. Okay, right. So let us draw a, assume that this is a circle. Okay, assume that this is a circle. So this is the center of the circle, and let us say this is a chord. Okay, and you have one more chord passing through center of the circle, right? So let us take length of the chord c. Okay, c is equal to what? Chord length of chord, let us say c as length of chord, and r is equal to, okay, r is equal to radius of curve, radius of curve. Now so, and v is equal to versine, v is equal to versine. So see, this distance is versine. Now from here to here, this distance is 2r. Okay, so this is center, right? Now total distance is 2r, so this distance is 2r minus v. Okay, so this total chord is C, so this is C by 2 and this is C by 2, so this is center O, right? Now before calculation we want to see a small concept of circle, right? So this was like, if two chords are intersecting, product of two parts is equal for both the chords. What does this mean? So let us say this is one chord and you have one more chord like this. So this is O, point of intersection. Okay, now let us say this is A, B and this is D and E. So from this, what does it mean? So A in O, this portion, into OB, this portion. Okay, so these are the two parts of this chord, is equal to DO. So this is DO and this is OE into OE. So product of parts are equal, right? So same concept we will apply for our versine. Okay, let us apply the same concept for our versine, right? So see here, so you have, if you see this chord, you have one chord like this, one chord like this. So here C by 2, here C by 2, this is V and this is 2R minus V. Okay, now if we multiply these two parts, C by 2 into C by 2 is equal to V into 2R minus V. Okay, V into 2R minus V. So from here, if we multiply them, okay, so C square by 4 is equal to V into 2R minus V square, right? Now this portion is neglected because V is small, V is small, V square is very small compared to R. So this portion is neglected. Now after neglecting, if you write the equation, okay, so after neglecting, if you write the equation, let us see how it looks. So C square by 4 is equal to 2RV minus V square. This portion you are neglecting. So 2RV is equal to C square by 4, which implies V is equal to C square by 8R. So this is the final equation of versine. So if you know this portion, you can easily determine this portion. What is this? Versine. Okay, this is versine and this is what? Chord. Okay, so this is what? Chord. So from this you can find out radius. So even if you are in field, if radius is longer, you need not find out that. You can simply find out by using versine and chord, right? So this is today's concept. In next part I will tell you, okay, some calculations using versine, chord and radius. Okay, how to do calculations using this. Next I also want to tell you, okay, uh, markings of versine stations. Okay, versine stations. Okay, so this thing we'll see in the next class. Thank you for watching. Thank you so much.